code challenges. They've definitely gotten tougher, and we'll see how it goes. So week 3, search in rotated sorted array. So suppose you have an array sorted in ascending order. Suppose an array sorted in ascending order is rotated at some pivot point unknown to you beforehand. So we've got 0, 1, 2, 4, 5, 6, 7. Okay, and it became 4, 5, 6, 7, 0, 1, 2. So it rotated at a pivot point, I guess you would call it between 2 and 4. And you are given a target value to search. If found in the array, return its index. Okay, otherwise return -1. You may assume no duplicate exists in the array. Oh, sorry, I've got the text tiny. Geez. Oh my gosh, it's too early, sorry. Alright, you may assume no duplicate exists in the array. Your algorithm's runtime must be in the order of O log n. Okay, so, I mean, I know half of how to solve this. So if the array was just sorted, we could do a binary search, which basically you keep dividing in half. Yeah, I woke up early today. I wake up early every day, but lately I've been going back to bed, and I highly recommend that for anyone who can. If you're doing a normal binary search, the way you get this O log n runtime is you just keep cutting things in half, so you look at a small fraction of the array. So, like, if this array was sorted, you would start in the middle. If it was greater than your item, then you'd go to the middle of the left. If it was less, you'd go to the right. And eventually you'd find your item. But here, we've got a problem because this thing has been pivoted. So, for example, if I was looking for a 2, and I came in here, I would say, oh, 7 is greater than 2, so let's go left. 5 is also greater than 2, go left. 4 is greater than 2, and there's no more lefts to go, so 2 does not exist in the array, but it does because we've got this crook in it. So this restriction here is also a really big clue. By the way, Vlad, check it out. My background still. Psst, 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 psst. So yeah, this is a clue because it tells us that we can't look at every item in the array. So the naive approach of just finding where the crook is and then maybe adjusting my indexes on the binary search isn't going to work if I just loop through. Now I might be able to find the crook the same way I did the binary search. Let's see what that looks like. So if I've got this and I was looking just to find where the array is messed up essentially, and they say some pivot point, not multiple or anything. So it'd say start here, 7. Are you greater than left? Okay, yeah, sorry, let me start over again. So we're doing we're doing a search. We need to find out how, if an element exists in an array in O of log n time. However, there's a problem with this array. It's been rotated at some point, some pivot. So for example, on the left we have a sorted array. This is what you usually use for finding things. But in this case, the sorted array has been kind of broken in half and reassembled backwards. So instead of being in order, it's half in order. So this half is, should have been in the beginning. And so if I try to do my normal binary search for, say, a 2, I start here, I go left, it's still 2 is less than 5, so I go left again, and I would say that 2 doesn't exist, but it does. So I need to find an algorithm that runs just as fast, you know, in big O terms. But I can't just do like my kind of normal, the standard technique. So I was thinking about trying to find where the array bends, where it rotates. I was thinking if we were trying to just find where it rotates, what we could do is basically compare any point against the first element. If it's bigger than the first element, that means it's part of like the bigger portion. If it's smaller, it's part of the smaller portion. So our goal is to find the spot, basically the first element for which it's less than the one to the left of it. So I was thinking about trying to find it with something kind of like binary search, because this is a hint. If we're looking at log n, that means like I have to do some sort of skipping around and only looking at a fraction of the numbers. So I was thinking if we found the point where this was, then we could just do a normal binary search, and we just have to kind of adapt our numbers a little bit to based on where our pivot point is. So, for example, if I'm just trying to find where it bends, where that first item is, I'm looking for the 0. And so I would start here at 7. I would say, is 7 greater than 4? Yes. That means that I'm still in the portion of the array that's going up. So then I could say, okay, 7, so that means I need to go to the right. All right. 1 is less than 4, but that doesn't necessarily mean it's the pivot point. We could get better. So I'll check the one to the left, and it's less than it. So in that case, I'll go ahead and split up the region between basically the item I already looked at before and this, which there's only one element. So in that case, I'll hop to this element, check the one to the left of it, and we found the pivot point. And so I think that's the secret to this one, is we found the pivot point in log n. So now we should be able to do just a normal binary search and kind of adjust it for this. And then that's it, and that will run an O of log n. You know, we'll be doing kind of 2 O log n algorithms, but 2 log n essentially boils down to log n because we're looking at growth over time, and 2 is a constant. So that's going to be good. The additional space is also going to be independent of the size of the input, so that's constant. So that's good. So I think this is a good solution. If we started at the end, what would that do for us? So going at the end, when you find the pivot, start from the beginning. I'm not sure what you're saying. I'm trying to avoid looking at every item because they say that the runtime must be order log n. So I can only look at a very small portion of my inputs, like specifically the logarithm. So if I get, you know, however many this is, 7, then I can only look at around the log of 7 items. So call it 2 to 3. Yeah, what's up, Greg? Yeah, woke up early. It's annoying. I tried to go back to bed, wasn't working. So I don't know if I call it determination, more like I might as well. I got my coffee. So the deal with this one is basically we've got a sorted array that got messed up. So on the left we have a totally sorted array, and on the right they basically took 0, 1, 2 and they pivoted. So it's like they broke the array at this comma and swung this part onto the end. And now I need to find if an item exists in the array. But the trick is that I still need to do that find in log of n. So what we're talking about doing is basically using something similar to binary search to try and find the pivot point. And if we do that, then we could do a standard binary search just with a little extra math, because then we could treat our array as if it were sorted again. So let's do that. Okay. And I'm thinking I'm going to do this over here. Do this in code. Whoa, too big. That was yesterday's problem. How you guys doing up on Sunday? I don't know yet, Greg. I don't know if it's early for you or not. Vlados, it's like, I don't know, early. Did you guys see the pictures of Florida yesterday? We made the national news. Yeah, log in. So that's the rub. Grab this input. We call this rotated. Sure. So I'm going to split this up into two parts. Basically, one is find the pivot. Two is find the number. Now, I'm assuming that given the pivot, I'll be able to easily find the number. So, I think you could do that. I think you can do that. And I think when it comes to finding the pivot, I mean, unless I'm missing something, I think it's not going to be that bad. Just to kind of say it out loud, what basically we will start in the middle of the range. So that means we need to have a range. So start equals 0. It's not going to be a const. Our end is going to start out at nums.length divided by 2. Okay. So this example is 7. So we get 3.5. Do we want to round up or down? I don't think it really matters. We go up. Oh, yeah. I had a big dinner last night, so I don't even want to think about it. Oh, and Vlados, hope you got a feast today. We typically do a ham on Easter in my family. Let's see. So start and end. So this will be 4. So now we got to find the pivot by basically adjusting those two numbers. So what's the while here? Awesome. Yeah, my family, no one ever trusted me to cook, so I would just get to show up and eat, and then I would have to help with the dishes. Start and end. End is really not this. This is like the midpoint. I don't know that we need to know the end, but I'm gonna go ahead and start with it. It's been a long while since I've done this binary search even. So how do we know when we found? Oh, it is. The lag is down. Oh, awesome. Okay, I changed a bunch of stuff, but I wasn't sure like which one did it. I'm gonna go ahead and do a recursive function called find item, and it should only run in a log n of time, so I don't expect to bust the stack, to overflow the item. Yeah, so we'll do it this way. Mind. Yeah, so I like doing these kind of challenges. So I was watching a stream the other day where someone was programming a game, and it just looked like fun. It's like, oh man. End divided by 2. Okay. And no while loop. We're just going to say find pivot. All right. And we'll start it off at 0 and nums.length. But I have to be careful because it's nums.length -1. I'm going to treat this as if it's an actual index. So our midpoint, test, yes. Test early. Good point. And I can do that if I split this up as much as possible. Good point. If I'm going to end up doing console.logs anyway, and I look, this one's a medium again, I'm going to end up doing console.log. This is going to be wrong, but I kind of just want to run the program early so I have less to debug. That's a great point. What do I call this? Node rotated. Okay. All right, there we go. All right, so we got 3. Is that what we expected? I expected to end up here on the 7, so 1, 0, 1, 2, 3. Okay, cool. So that's good. And what if it was an even number of items? Then I expect to end up, which one? I did say sailing, so I expect to also get 3. Let's try that. Yep. Okay, cool. So that's not exactly a unit test, but I don't want to write like a separate function in a unit test just for this one line. So then we'll be writing a lot of tests and a lot of functions. But yeah, I'm being lazy. As always. Oh, and look at this. It should have been start. It should have been start plus end. No. End minus start. Divided by 2. So, yeah, let's try just doing that a little bit. So if I say find pivot between 0 and 7, that should still be the same. Okay, 3. And I'll just return nothing for now. Just get rid of the undefined. Alright, so what if I was trying to find the difference between, let's say, 2 and 3? What should it give us? It'll do the ceiling, so it'll do 3 minus 2, 1 divided by 2, 0, 0.5 rounded up will be 1. So I expect it to give us the bigger number, basically stay the same. So between 2, did I say that right? 2 and 3, and I ended up with this number. Is that what I expected? Yeah, that's a good point. Good point. I tell my wife all the time when I don't do things that I'm not sure if I ever need to do them. Yakni. She doesn't like that. Like, I don't know. I don't need to do the dishes because the world might end tomorrow. And it won't matter if I did the dishes. I'll do them as needed. Alright, was that the right answer? So in this case, we said between 2 and 4. No, sorry. Between 2 and 7. That's where I messed up before. And came back with 2? That's not right. Yeah, what the heck? So the distance between 0, 1, 2 and this one, I should have gotten like this item, 0, 1, 2, 3, 4. So what is the difference here? It's end minus start for sure. So we got 5 divided by 2 is 2.5 rounded up. Oh, you're right. I passed a 6 though. All right. Yes, definitely. This one's going to go well, I think. So here we got 0, 1, 2. So 2. That's still not the right answer. What the heck am I doing wrong? Why am I dividing by 2 anyway? So it should be this plus start. Okay. Man, I'm so glad you said to test here. So that's right. So we do need to offset it by wherever we start by. So I feel good about our pivot number now. Got the answer we expected. So I'm going to put this back to normal. And we got 0, 1, 2, 3. So still got the good answer. All right, good. Found a bug early. So that's our midpoint. Now what? If the midpoint, I need to know my nums. That's true. I did say the exact same thing yesterday. You should see my estimates at work. Oof. Very optimistic. All right. If the item at, sorry, not start. If the midpoint is greater than, I'm going to copy my example up here. We're looking at the 7. I say if you are greater than the first item, I think that's good. Then what? Then I know that you are still in the bigger half. And so I need to go to the right. So I'm going to return find pivot, pass our nums again. Now this time the start is going to be our midpoint. And our endpoint. So we start here. 7 is greater than 4. So now we're going to find the midpoint between here and there, and we're going to hop to the 1. Okay. Now 1 is going to be smaller than 4. So what? What does that mean? If nums at mid is less than, and they did say that it's only unique values in the array. So now if it's part of the lesser half, then what does that mean? What does that mean? It means that could be our pivot point, or it could be just in that half. In this case, it is just in that half. We're looking at this item. What I kind of want to do is basically say something like, this is probably not elegant. Might be a better way to do this, but I want to say like, if mid is greater than 0. Oh, yeah, sorry, I forgot to show the pictures. Oh my gosh. Is it Florida Moron Beaches? Oh, we're gonna get a video. No. Yeah, so there are our beaches. This is actually about 2 hours from me. Yeah, and look at that. This is at like this picture's at 11, but people like started lining up at 5 a.m. like real early. And then yesterday in Orlando there was a protest too. More on Orlando protest. So yeah, people gathered to protest. So awesome. Oh gosh, another video. No. Anyway, it wasn't that big. I'm surprised they didn't get arrested or ticketed or something. But yeah, thank you. I hope it works out okay. So if the midpoint is greater than 0, then what I'm going to do is basically just check nums at mid minus 1. And if nums at mid minus 1 is greater than us, nums at mid, then we can just return mid because we found it. That's it. But you know what? Why not check? We need to basically, this is a recursive function, so I still haven't figured out like the kind of the end case. And this is the end case. So maybe this should go up here. And basically if nums if mid equals 0, is that ever going to happen? Can mid ever be 0? If it was 0 plus 1 minus 0 is 0.5. Rounded up is 1. So there's a flaw in my array. I shouldn't do ceiling, I should do floor. Otherwise, I'll never look at that first element. So another good one. That's a problem. Okay, so now if mid equals 0, or nums at mid minus 1 is greater than, so the one to the left of me is greater than me. Then return our mid. This is our stop condition. Okay. Otherwise, we're going to go to the right. We'll find the pivot. Feel good about that. And then we don't need to check this. Yeah, so 4 is a new type of equal in ES 2020. It's for when you really, 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 really need to be sure that the numbers are the same. It's the bridge operator. Equal. Yeah, I love those ligatures because they make stuff like that really apparent. Alright, so if the mids at our item is less than our 0, and then we know that it's not the answer. So this is basically the situation where we end up like right here. This is less than 4, so we need to travel left. So actually this becomes easy. Find pivot. We pass nums again, and this time it'll be the difference between start and mid. And then what? The only other case here is basically if it should never happen because they tell us there are no duplicates in the array basically. So I'll leave that. So I think that's good. Let's try it. And I'm going to be lazy and just return pivot so I can not console.log. Okay. So now this is calling search, but it's just going to return the pivot. So in this case, I'm passing this number, and I want to get back the 0. So the first element. Sorry, what should be the first element, which in this case should be 4. Let me just do that. It's better. Oh my gosh. Oh, hey. It's our old friend. Whoa. Pivot is not defined. It's called find pivot. Not a number? Okay. Not sure what happened there. Well, let's step through it. What? Oh, geez. Okay. I forgot to. Yeah, let's just do search. It returns pivot anyway, and it saves some typing. Oh no, I want to keep this test around, I guess. So, all right, fine. My laziness is found abound. And I'm passing 6 because it's the index, not the size. Okay. So, hey, we got our answer of 4. So it found this item, and it found it, most importantly, in log of n. So what I was kind of saying is, like, if we can find the pivot in log of n, then I think we can essentially do a binary search and also in log of n, and our runtime just ends up being log of n, because even though I'm doing it twice, that 2 is going to fall away, and then we'll be good. So it's going to be a modified binary search here. Do we want to do any other tests here? So yeah, let's just do one like this. Oh, that should be 3. So in this case, I expect the pivot to be 0, which is valid. Hey, look at that. So here it should have gone 6. And then it should have gone 5. And it should have gone 4. And then I thought I had a check here to see if mid equals. Oh, shoot. Should have been. Should have been this. All right, so let's just look at the mids. And again, happy to test here. This looks like we found an issue early. There's like that stat about there's that stat about basically the faster you find a bug after you write it, the easier it is to fix. Is that MTF, mean time to fix? Or no, it's the letters are weird. It's I think this is total divergence, but mean time to find. This relationship between mean time to find and mean time to remediate. So the lower this, the lower this. Let's see. That's like the only white paper I ever read. I don't even remember what it's called anymore. I should read those. We should do like a papers we like, papers we love. Papers we love group. Anyway, it's all computer science papers. All right, so somehow I ended up going off the rails here. So we'll say start, sure. Wait, I keep forgetting. I want to get out of the habit of console logging so much, so I'm just going to debug it. It's a little better. So 0 plus 3 minus 0. It's going to be 3 divided by 2. 1.5. Floor is 1. So start was 0. So we should get a 1 here, and that's good. So we skip. So mid is 1. Mid is not equal to 0. Nums at mid minus 1. So 0. Are you greater than nums at mid 1? And the answer is no. So we should continue on. And we said that nums at index 1, 5, is greater than nums at index 0, 4. So we should go and find why did I go right? Oh, I should have gone right. Because the number at 1 is greater than my number at 0. So I'm telling it that it should still be to the right. So I basically need a stop condition. Let's see here what that looks like. So now we're saying the mid is 2, 0, 1, 2. Oh, this is the array we're dealing with. So 0, 1, 2, okay. And it's not equal to 0, and it's not less than the one before it. That's not that. It was, yeah, so that was the right thing to do. I skipped too fast though. So now our mid now is the same. So our mid is the same as the start. Does that mean anything? So basically we got an infinite loop here. So how do we detect an infinite loop? Is it just if the mid equals the start? Yeah, I think we could say that here. If the mid equals the start, then we can return. And if that's the case, we've basically searched everything and we verified that it's not the winner. So the only other possibility is that it's 0. Okay, so let's try this again. We got 0 this time. Do we still have the right answer from before? Yeah. Alright, I'll go ahead and do one more test case just in case. And what answer do we expect here? We expect the last element in the array, so that's a good test. So we should get a 4 here again. Okay. Yay. No, that's not right. So what happened here? We went 6. And we should have gone 7. Oh, this should have been 5. Is that right? No, it's the last index here. 1, 2, 3, 4. Yeah. Okay, we got a bug. Good to find it early. So what happened? We started here. We should have gone right. You know, I never checked the 1 to the right of me. My sleeping dog just squeaked. And then I don't check for that. So is this the case where here we're mid? I think this is the case we ended up on. So let's try running this. Let's eliminate some of this noise here. So mid equals start. Nope. Okay. So now we've got mid doesn't equal start. Okay. Is mid at 3 greater than num at 0? Yep. We come back around. And we got 3 equals 3. So here I'm just always returning 0. But the problem here is it's actually the one to the right. And I do check this condition. So what I need to do is something very similar here. What is end in this case? Can't see it. End is 4. So if the item above us, so if we'll just do this as a whole separate case. If well, we never have to worry about it equaling the last item in the array. I don't think that will ever happen. Right, because it's always the floor. Okay. So, if the item to the right of us is smaller than us, don't I check this down here? No, mid plus 1. If the item to the right of us is smaller than us, then we can just return mid plus 1. So that was the case that I was missing. Okay. All right, good, right answer. Make sure we didn't break the other ones, and then that'll be the 3 main test cases. We test even number of items, odd number of items. I feel pretty good about those tests. Okay, so we found the pivot. And I think that was the hard part. So now we need basically a modified search. It's going to look very similar. And it's going to take nums. It's going to take the number we're looking for and a start and an end. Oh, I already got one named search. Oh, it also needs to take the pivot. That's a lot of stuff. Pivot search. Okay, there we go. So I'm gonna keep things similar. And it's gonna return the index. So I guess I could say just kind of, well, we'll get the midpoint, same as before. But if nums at the midpoint equals target, then we return mid. And this should always happen. We shouldn't have any other use cases. Oh no, that's not true. That's not true. If it's not, we do have the possibility that it won't ever find it. So something, if something, we'll have to return -1. So it'll be something like above where it's like, if mid equals start, and they're not equal, then we have nowhere else to search, and so we didn't find the item. This might be off a little bit though. What's up, Abdul? I'm up early today. You guys are like eating lunch. Have you done today's problem yet? I'll spare you repeating it if you've already done it. Search, start. Oh, and this is not, this formula is not right anymore. Excuse me. Yeah, I woke up early and I stayed up for once. I used to always wake up early and stay early, but then I discovered I could just go back to bed. And I think I got the latency down. Vlado said it was better. Man. Yeah, I need to do the thing with the pivot here. Yeah, so my thought was basically to see if we could find the pivot in logarithmic time. And then from there, I thought we could do a modified binary search and find the item. Just kind of adjusting for the pivot point. So we found the pivot, and that worked out really well. We got a couple tests written here, and it, you know, there's a couple cases. I could probably cut this fluff down a little bit, but basically it's just a binary search to find the one where it's, how do you say it? Like where it's, the one to the left of it is greater, basically, or else return the first element in the array. So that's all it does, and that's been going well. And now I basically need to kind of transmute this kind of range. It's tempting just to slice the array to kind of fix the array and then find it and just fix the result. But that's going to end up being an order of n operation. It's going to mess up our runtime, which is silly. I mean, it's not silly. It's just, it's a bummer. So, you know, I thought that we had done the hard part by finding the pivot, but now I'm realizing that maybe this is also hard. So before I start coding, let's see if I can actually figure it out by hand. So in this case, we know the pivot is at 4. Let's start with a much smaller example. So if we looked at like 1, 2, 0, my first part's going to find out, I might as well check it, that 1, 2, 0, that the pivot is at 2. Let's make sure that's correct. Oh my gosh, look at that. Found another bug. So I should have found, oh, I didn't set the boundaries here. I forgot some arguments. Okay. Phew. All right. So 1, 2, 0. I know the pivot is at 2. Like this is where the mess up starts. Now, in order to find it, yeah, exactly. That's exactly what I'm trying to do. It's too early for math, though. So now I'm just trying to figure out basically that that math part. Like, what does it mean? So now I'm going to start at the middle, doing a standard binary search. Except I'm trying to figure out like what my start and end to, like I just haven't really like internalized what it means now to know that there's a pivot point. So when I have a pivot point, I don't just start here and there. Really, my start is now my pivot. So start point is 2 going in, and the input, the 2 minus 1 is the end. So end is 1. So what the heck is my midpoint? What's the midpoint between 2 and 1? So I don't think I'm gonna be able to think about it that way. I'm just gonna have to think about it in old terms and then transmute, just like you said. So start is 0, end is 2, mid is 1. But now when I go to check the midpoint, that's when I do the math. So we'll call it like, I don't know, actual mid. Or, I don't know. I need a shorter word. Modified mid. And that will be pivot plus mid mod length. Is that right? So in this case, that would be our pivot of 2. Go ahead and just write that like this. Pivot of 2 plus the mid, which is 1. So we're looking there. Mod the length. So that would be 3 mod 3, which is 0. Okay. Put parentheses in here. So I think that's good. All right, and then we would say, is this our target number? And if not, we go greater. Otherwise, we go lower. And I think that's good. I think that's enough. So let's say, I would just call it find target. Okay, so kind of do this again. Well, let me keep that actually. So that's our, and maybe we'll call this like logical mid or something. And then const. Then I'll say our actual mid is this. Our pivot point plus mid modulo nums.length. Okay. So at that point we have all of these numbers. Okay, so if oops, and this is going to be logical mid. Okay, so if that's our number, then we return the index. If our logical mid equals our start index, is that right? Then that means we've looked at all the items and we verified that it wasn't it, so we return -1. Now, we're not quite out of the woods yet. So we need to check if nums at mid is greater than what? Greater than target. That's fine. Okay. I think I still have a problem here, but I think we have to transmute that start and end too. But I'm just going to do the rest of the algorithm because I think this part won't change. Basically change the inputs. So if nums at mid is greater than our target, then we need to go left. So return find target, go nums, target don't change, our pivot doesn't change, our start and end do. Start will still be start. And this will be, is it our mid or our logical mid? I think it's going to be our logical mid. And so I think yeah, we got to figure out a logical start. Okay. So we'll just call this logical start. Logical end. Okay. And then we just fix it. And then that makes actually figure out the logical mid a little bit easier. So it's pivot plus logical end. Mod the length. Cool. Now, I don't need to... I don't think I ever need to know logical mid, do I? Maybe not. I don't know. So start is now the real start. Geez, I don't know. I'm getting tripped up again. Let's just do it. Logical mid equals the midpoint between the logical start and the logical end. Logical. I'm already hating that I chose the word logical. Super awkward. Alright, and then the mid is just this same kind of function. Logical mid. Alright, now I'm just gonna check how that works out. I know I just said I wasn't gonna console log anymore, but I feel like I need to do that here. I kind of want to see everything. I just do like start. Logical. No. Logical. Like with something about the 8th one, or 9th one, I just can't do. So I had to count my fingers there for a minute. And logical mid. Do these first. It's hard. Did you try it? Let's see here. Try saying logical 10 times fast. Find target. Alright, so I already forgot all the arguments here. Collapse this. Alright, so our nums, there we go. Our target is, I don't know. We'll test the happy path first. We'll test for 0. And then what? Our pivot is, in this case, it's going to be 2. Our logical start is 0. And logical end is the length minus 2. Or sorry, minus 1. So, I've never been, I could never speak fast like Eminem or some of those rappers. I can't. Geez. Okay, I think that's good. It's kind of fun to try it though. As fast as you can. I wonder what's the etymology of the word logic? Logical. It sounds like algorithm and algebra to me. So I wonder Logic. Etymology? Okay, Greek logos. Alright. Now we know. Alright, so find target. And in this case, it should return, if we're finding a 0, it should return 2 equals. But it's not going to get that far. I just want to see what the output's going to be. Alright. Logical start with 0, cool. Logical 2, cool. Logical mid, yeah. So in our case, though, we said the start was 2, which is true. 2. The end was 1, also true. Wow. Logical mid was 1. That's not right. Did I do a typo? Logical mid equals... Oh, logical mid was 1. Yeah, that's right. Okay. And then we ended up with start being equal to 1, which is incorrect. Oh, no, sorry. I'm looking at the wrong thing. Logical mid was 1. Good. Yeah, so start, end, mid. So that's all good. That actually worked out. So maybe I just passed things wrong down here. So numbers at mid equals target, return mid. Now, what was I trying to accomplish here? So I shouldn't really care about those logical ones in my algorithm. That's the whole point of transmuting, right? If the mid equals the start, then we give up. Okay, I gotcha. So the logical. Yeah, I guess I do the top of the... Yeah, I don't speak any other languages. It's terrible. Every once in a while, my dad was a French teacher, actually. He could speak French, but I didn't learn. Start and mid. Now, do we pass the actual... Oh, we pass the logical start and end. Okay, so here we should do the logical start and the logical mid. But French and English aren't that different. Like, it's not like we use different sounds. We're both, what do they call it, romantic languages? Is that right? Now for less than target, same thing. We pass num, sure. Target, sure. Pivot doesn't change. Now here, we just do logical mid and logical end. And I think that's it. In this case, it should never happen. So we'll turn null, sure. That way if we see a null, we know something went wrong. I have a process that runs at 8 in the morning. It's funny. That's for QIT. 2 equals 2. Hey, that's the right answer. It's logarithmic time. All right. Let's try this input. Yeah. Yeah, it doesn't sound very graceful to me. I do like English accents, like from people from the UK. So if I'm trying to find, what was the example they gave us? Target 0. Given this array, we should return 4. So 4. So we're finding the target. There's our array. And geez, my brain stopped working. But we pass, oh there it is. Nums, the target is, I already forgot, 0. Okay. And the pivot in this case is 0, 1, 2, 3, 4, which we've got above. Yep, so right answer, cool. The start is good. This is logical start. Oh, hey, look at that. Autocomplete. And the logical end is the length -1, so 6. Okay, and we're looking for a 0. We should find it at the 4th index. Yeah, okay. Which also happens to be the pivot. Let's see if that works. Yeah, we got it. Cool. Let me comment these out for now. It's confusing me. Everything looks good there. Alright, let's try another sample, but we might have it. If we look in the same array for 3, so the target is 3, then pivot stays the same. We just expect a -1. Alright. Oops. So let's try it. I'm happy with the runtime. Oh. I still haven't put these two together. That's funny. So now find target. And it's nums. Find 1 and 3, find 4, yeah. So we'll, what's the answer we're looking for? We're finding 4, so it should be -1. Find target of 1 and 3. And I'm hoping that the search is going to find the pivot at 0. So we could check that too. We have 1 and 3. We start at 0. The last index is 1. We should get a 3 here. I'll comment the rest of these out. Alright, -1 equals find target 1 and 3. The number we're looking for is 4. Did I get that order right? No, oh yeah, it's right here. Duh. Nums, the target, and the pivot in this case should be 0, but we'll see it for sure up here. Should be 0. And it should be 0 and 2. Oh, sorry, 0 and 1. Alright. Let's see what we get. -1. Okay. And so did I do this right? Let's just do it down here. Find target. Oops. Find target. Nums. Yep. Target's target. The pivot we get above. Logical start is always 0, and the logical end is always going to be same as up here. All right. I guess I don't need those comments. So we actually have decently named functions for once. Okay. Moment of truth. Oh, really? 0. Let's see here. So what happens with 0? Where should I handle that? Should have been 0, and 0 minus 1 is -1. So here I've got a find pivot. I think I might just check this down here. It seems a little easier than trying to worm it into both these functions. So nums.length equals 0. And whatever we're looking for is not found. I'm happy with that. All right, let me rid of those comments from here. This is the problem of working with two editors. All right. Hey, didn't we check this? 1, 3, and looked for 0. Didn't try looking for 1. I guess I have an off by 1. One, 3. And the number we're looking for is find target is 3. So when we're looking for 3, well, I will leave that test. So we look for 3. What happened here? 1 equals -1. Did I mess up that new condition I just added? And search. If num's length equals 0, no, that's fine. So what happened here? I found the pivot correctly up here. So the problem is in find target. Oh, I got this wrong. The first number is the pivot. So I did this test wrong earlier, where I did the 4. It should be pivot. No, that's right. Target and then pivot. Okay, yeah, that's fine. Look, I'm never using end. How does that work? How am I never using end? Very suspicious that I never actually used the actual end item. All right, let's just step through. All right, debug this thing. Pivot 0, that's good. Logical start 0. Nums.length is 2. Okay. That's all good. So close. All right. We find our end, but we never use it, which I still find suspicious. Our logical midpoint is 0. Okay. And our actual midpoint is 0. Okay. Because, yeah, that's right for the input we're passing. So if nums at 0 equals our target, it doesn't. Then we go on and check if the midpoint equals the start point. Okay. And then I bail on that. That's not sufficient enough. This is not a good test case. So is it as simple as saying, because I haven't used end, which is suspicious, so can't I just say if nums at end equal target? It feels something weird about that, but return end. So this should give us the right answer now. Yep. Let's check all the other stuff. Do a little bit of cleanup here. See if we got all the other answers. Yeah, okay. So cool. Let's give this a try. All right, that worked good. And let's try submitting, and this is it. Yay! Now, as far as runtime goes, I'm sure somebody figured out how to do this in one pass, so I don't expect a great algorithm here. Okay, so we're somewhere in the middle. Solutions. Start, less than end. Okay, if it's found. What's the, trying to figure out the general strategy. Submit on left side. Heck yeah, in less than 3 hours too, doing pretty good. So this does a single pass. I don't quite understand what the point of this solution is. I do want to see like the very, like kind of the ones at the top end. Doing something very similar. So they're doing a single pass, which is nice. I did 2 passes. They get the mid, while start is less than the end. Yeah, I think you're right, Abdul Rahman. So every other solution I'm looking at basically did what you said. So I think that you're on the better path here. It's all the ones faster than me all did 1 pass and did exactly what you're saying. Binary search with just a couple extra checks. So I kind of squeaked by on a technicality by doing finding the pivot first. Let's see, what do the worst ones look like? It's funny, I've yet to see another solution that did what I did. Found the pivot first. So it looks like I did something weird. So it's weird that I ended up in the middle of all these other solutions that all do 1 pass. So, well, that's cool. All right, well, good. I'm going to get out of here and get another cup of coffee. I'll be back on later, probably on YouTube, with Michael Outlaw looking at drill, Apache drill. So we're going to try and find a big data set and then try to do some interesting stuff with it with Apache drill, which is like a querying language for querying different data sources. So you can query files, or you can query a database, or you can query other stuff. And should be fun. It's like a big data kind of thing. So check that out if you're interested. All right, check you later, and good luck, Abdul. I'd love to see what you end up with. Send me a C++ share.